Hey guys, and welcome back. Today we'll be talking about special right triangles today. So there are two kinds of special right triangles. This one is one and this one is one. As you can see, these two triangles are different based on their angles. This one would have two congruent sides, while this one would look like this and doesn't have any congruent sides. So special right triangles. So we know right triangles are 90 degrees. So both of them will have a 90-degree angle at the right angle, which is here and here. And so we're talking about the first one here is the 45, 45, 90 special right triangle. So the name given to each triangle is the measure angle that is special about the triangle. So here we have that this triangle has both 45 degrees on the corners that aren't a right triangle or a right angle. So this one is called the 45, 45, 90 triangle. And then the next one is called the 30, 60, 90 triangle. So the smaller angle would be 30 and then the bigger angle would be 60. Well, that doesn't matter, but if you can tell, yeah. It would tell us if it's 30 degrees or 60s. And then the right angle. So this one is 30, 60, 90. So the reason why it's called special right triangles is because of its angle measures, we have a special way to solve them instead of using the Pythagorean theorem. Of course, we can use them, but this is another way. And again, as a refresher, the Pythagorean theorem is a squared plus b squared equals c squared. Just a refresher, but we're probably not going to use it in this video. Okay, so first we're going to go with the 45-45 triangle. So we can remember this one by it having two of the same angles. So that means these two lines would be congruent, because if it wasn't congruent, we can go down. If it wasn't congruent, like this line right here is longer, it wouldn't. So let's say for example we have a right triangle here where this length down here, this leg is greater than this leg. We can tell that these two angles aren't the same. So if we have a right triangle or right angle and two of the same measure, then that means that the two legs are congruent. So I labeled those two x because if we know what x is or what one of the legs is, and then we can find out what the hypotenuse is, which is this. The hypotenuse is always the diagonal, or it is always the line that's opposite from the right angle. From one leg, it would be square root of 2 times x would be the formula. So let's say x equals 3. So if x equals 3 and both of the legs were x, then both of them are 3, and then, or the question probably won't say x equals 3, but like one of the legs equals 3. So then we can erase x and then put parentheses and 3 there, because, so yeah, basically not really x, but the length. So to find the hypotenuse, you would multiply one of the legs times the square root of 2. Or if you do the opposite, if you're given the hypotenuse, you know that one of the legs times square root of 2 equals the hypotenuse. So then you would divide the hypotenuse, divide it by square root of 2, and then it would give you 3. Let's say we don't know the answer to this equation, but if we do divide it by the square root of 2, it would cancel out the square root of 2 and give us 3. So it would work. So I put it back to the actual formula. We'll keep it like that. And now we're moving on to the 30-60 triangle, which this one you do have to remember more. So because this one only has one side that is plain x, just x all by itself, which is the shorter leg. And we know it's a shorter leg because the angle across from it is 30 degrees, and which would tell us that it's shorter. The longer side of this 30-60, longer leg is the square root of 3 times x, and then the hypotenuse is 2x. Also, you can tell that a leg is shorter by the angle that is opposite from it. So 30 is the shortest angle out of all of these three angles. So we know that the side opposite from it is shorter, or the shortest. So this is something that you just need to remember. But like in this 45-45 triangle has the number 2 inside the radical or the square root. And I guess you can like think that there are 2 kinds of degrees, 90 and 45. So since there's 2 45s, but it's still considered as one kind. So you can think that is why there's 2 in there. And then inside the radical here is 3 because there are 3 kinds of angles. But you do have to remember that the radical square root of 3 times x is on the longer leg of the 30-60 triangle. And I think it would be easier to remember that x all by itself is on the shorter side of the 30-60 triangle. And we can think that because when you say 30-60-90 triangle, it starts with 30. So we can think that it starts with normal x, because on the 45-45-90 triangle starts with the normal x, and then 90 is square root of 2x. And I'm talking about like the angle and the side that it goes to, or it corresponds, or is opposite to. So it goes with it. So 90 goes with square root of 2 times x, and 45 goes with x, since that's what the side it is opposite of. And the hypotenuse is always the longest side, so I guess you can think of it that 2 is greater than the square root of 3, so 2 would belong on the hypotenuse, not the longer side. Because I used to have that mistake. I would think that the formula for the longer side is 2x, and the hypotenuse would be square root of 3 times x, but no. So yeah, but you guys can comment below. Maybe there are easier ways to better help you memorize these special right triangle formulas, but that is what the special right triangle formulas are of 45-45-90 and 30-60-90. So thank you for watching.